So we don't even know what the question is about, but you're either finding the mean or you're using something about the data or the information there to determine which is less and which is greater. And you see this all the time in college. Like you see it's so many times in college. If you've ever had it, have you taken an econ class yet?
No.
Okay. There are questions in some classes where they multiple choice lends itself really well to like both go up, like up, or increase, decrease, increase, increase. And you see these all the time. So you have to, you obviously have to know how to solve the problem, but in this particular example, there's something about the mean that you're looking for. So now I will snip in the question and we'll kind of look at it together, or maybe you'll know the answer right away. Um, we need to do something about the mean. You don't need to read this as which of the following statements correctly compares the means of A and B. It's a which of the following, which of the following. That means you got to look at the answers. So let me just make this a little smaller here. Data set A, data set B. What do you, and you can do the same thing up here. Like, what do you notice that's kind of the same or different about the data sets? You don't actually want to calculate the mean. That's slow. You want to try to determine it without calculating the mean. Like maybe noticing something about the numbers.
Data set A has like greater values, so its mean
Yes,
would be more.
exactly. So which answer would that correspond to?
Um, D.
Yes. So sometimes by looking at the answers and the kind of trivial examples, you can say, okay, well, I know I'm going to find the mean, or I think I am, but then you realize, oh, I don't really need to actually calculate it. So if you read it from top to bottom, you might actually calculate the mean, which is slow. Everything I'm showing you is about saving time, lots and lots of time. All right, so let's look at another set of multiple choices here and do the kind of the same thing. So here are 4 multiple choices. As R increases at a constant rate, V increases more rapidly if interest is compounded annually rather than daily. As R increases at a constant rate, V increases more rapidly if interest is compounded daily rather than annually. What's the difference between A and B? You can read them one more time if you need.
The rates compounded at.
Yeah, one's annual, one's daily. That's the only difference. So we might tend to like go towards, well, maybe it's probably that one. C says as R increases at a constant rate, which is similar so far. The difference in interest compounded daily and interest compounded annually, well, this one's totally different. Increases at a constant rate. All right. So compounded annually increases at a constant rate. And we're not sure if that's right or not, but we can see that it's very different than A and B. If R equals 15% and interest is compounded annually, a $1,000 investment will be worth $20,000 after 20 years. Okay. So having said all that, do you feel like um, you know enough here to answer this question without even looking at the question?
Um, Maybe.
Okay. Like, could you tell me why A is wrong? It's okay if you can't. I'm just throwing that out there.
Uh, because it would compound faster if it was daily, not annually, because it'd be more frequent.
Yeah, exactly. So A is wrong for that reason. Is B correct for kind of the reverse reason?
Yes.
Yes, exactly. So the answer is actually B without doing anything. So I'm not saying that that always happens, but you got to be on the lookout for stuff like this because here's the actual question. And it's one of those where like some students might say, oh, there's always an impossible question on there. I mean, is it impossible? Well, I don't know. There's a chart, some words. The graph is kind of interesting. It's important for you to know as someone who's going to someday, have an income and want to maybe put some money into, mutual funds or stocks or a home or something. Like, you want your money to compound more rapidly because you get greater gains on that at the same interest rate. So,
Mm.
it's like, well, did you need if you read this from start to finish, you may not be able to answer because you might be so overwhelmed by it. But if you look at the answers first, you might be able to figure that. Now, D is wrong because 15%, uh, it's the wrong one. Annual is below. It's the daily. That's 20. That ends up being $20,000. So just you can also do that to get to your estimates. The correct one here is B. Uh, and like all the other strategies, like there's no guarantee of this strategy working all the time, because here is an example of where uh, the answers don't really even help you, but you should be aware of what they are. You want to know what the answers are so that you can know what to look for. And see, these are more word problems. I think last time we did some more of solving. Um, which of the following is true based on these data? The bus had the most riders on Tuesday. Okay, maybe. The bus each day from Tuesday through Sunday, the number of riders in the bus was greater than the previous day. Each day from Tuesday through Sunday, the number of riders in the bus was less than the previous day. So notice that those are there. So almost always you'll get one of these where it's like greater than and less than. The 2 days with the fewest number of riders were Saturday and Sunday. And again, these are all which of the following. Which of the following? So here we go. Let's look at the actual question. Now that your brain is kind of thinking about it, go ahead and see if you can answer this for me, please.
It's D.
It is D. Do you think it helped having the answers there first, looking at them first to try and go back and look at which
Yeah.
data is useful to look at? Really is that, I mean, that's the way your brain works. When my brain works, like we really need to consider, what reality is, which is that you if you know what you're looking for, it's a lot easier to find. You don't go to your phone GPS and you type something in so that you know where to go, and that's the whole point here. All right, let's
Mhm.
look at some more questions now. This is kind of the point where it's kind of your choice here if you want to start using this strategy. You do not. You can we might have actually already looked at this one in another lesson, but you can see here it doesn't just apply to like word problems. Here's a which of the following describes the solutions to the above equation. So when we talk about like what's the same and what's different, like these are numerical answers, meaning that
Mhm.
the numbers that work, these are the exceptions. Okay, and does this help? It actually doesn't help in this problem. Like, you have numbers, you can either try the numbers, like 0 might be good to try just because it's easy. 10.5, not so easy. Um, these other ones come from trying to work it out, like kind of the direct way, like you would have in the classroom. So I'll leave it up to you here how you proceed from here. And there's no right or wrong way. There's just, how do you do it?
Solve the equation.
Yeah, either solve it or try the answer, or you could guess, I suppose, but it's not guess at this point.
D,
Okay. And how confident are you in your answer?
pretty confident.
Okay. Tell me how you came up with D. What did you do?
Because the equation would be 7x minus 7 equals, I mean, 7 over 2x minus 7 equals 7 over 2x minus 49. And
Right.
7 over 2 minus 7 over 2 is 0. And 0x doesn't equal.
Now, did you
Um,
did you did you keep like trying to work it out here, or did you just see it from this point right here?
I saw from
These
here.
are this is good because there's no partial credit, there's no graded work. The fact that these are different, good enough. So keep that in mind. Like you don't have to show any work. You're correct. It is that there. And it looks a lot harder than it actually is. You notice some of these things. They're designed this way. Okay. This one's a lot like one of the first ones I talked about with mean. Let's do one more here for this, and then we're going to talk a little bit about something I think we talked about last time, but we'll address it here. Go ahead and see if you can work this one out, please.
Is it B?
It is B. How did you know that it was B?
Because, like with the question from before, it has a greater range of values
Yeah,
and
all of
like
this
higher
is the same.
values.
Yeah, all of this is the same, but then there's this one little difference,
Yeah,
and that really helped to do this. It gets a little bit more complicated if, for example, let's just say like, I don't know, something over here was lower or something like that. But because it's the same and these questions are designed this way, like this is stuff you should look for, it helped you to answer these questions. All right, so just kind of as an aside here, because well, we'll get to that. Yeah, let's keep going here. So let's do a few more. Um, and I'll address that later. So I'll throw a few more questions up in front of you.
is it D?
You seem uncertain slightly. Maybe it's just the early morning. It is D. Very good. This is what's really important about square root problems in particular. You can only take the square root of certain numbers. And you know this. You know this. At some point you learn these. I don't know how far up you know, but you know quite a ways up. Would you agree with that?
Yeah.
Okay. Um, did I miss one? No, started there. Okay, and these go up, right? Like so the question is like how many of these should you remember? And it's like the answer is I have no idea. But let's say I give you a problem where it's the square root of x minus 30. Okay. Well, what are some reasonable x values? Well, 30 is okay. Why is 30 okay? Because it's the square root of 0, right? 31 is okay because then it becomes the square root of 1 and even 34, right? And so on. So when you're looking at something with a square root, you want to not look at the answers. You want to look at what numbers actually work in the square root. Okay. Now, in the case of like, let's say it's the square root of x plus 5. Does x equals -1? Does that work?
Yeah.
It does. It looks odd, right? Because what they're trying to get you to do as a student is say, oh, I can't take the square root of a negative. That one's out. But it's not a negative. It's the square root of 4. That's
Mm-hmm.
good. Okay. X equals -4. Is that okay?
Um, no.
-4 plus 5, that was 1.
Oh wait,
Square
negative
root of
four.
1.
Sorry, I thought you meant like,
Right,
yeah.
right. So then that's the whole thing is it's like you're however the brain works, we don't really know, understand fully. Like you're somehow looking at it's like, oh, it's the square root of -4. It's like, no, 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 it's -4 plus 5. And that's
Mm-hmm.
okay. And so there's specific things that you, especially with square roots, and this will save you time, so that you know, okay, it's not that because this number is negative, it's when you put it in here, does it work out? Does it work out? Okay. And that's what you have to be on the lookout for with this. So let me go see if I can grab a few more of these square root problems for us to do real quick to kind of get this idea down. Let's go. I don't think this is basic solving. Trying to find some problems here. They're not grouped well for the. Let's see if this isn't here. All right, one more minute. Multiplying powers, polynomial multiplication equations. Okay, can't find it. We'll just keep moving on here. All right. So we're back to just this whole strategy of which of the following, maybe look at the answers if you want. It doesn't always work, works well for word problems, not so much for like sort of these advanced algebra problems. Let me know if you have any questions. I'm happy to provide some explanation before this.
I'm just a little confused on
Okay.
how to
So
solve
so
this.
there's yeah, so there's two things to remember here. You learn these at some point. One is f of x equals 0. And what this means is there's a couple of ways to think about this is these are where it crosses the axis because this really means that y equals 0. So these are like solutions, or sometimes you hear the words like intercepts, things like that. The other one is f of 0. This is the y-axis. This is when x equals 0. This is the y-intercept. So you have to know the difference between these two. This is just a note card or something to get this down. The question is asking, if I could use just plain English, it's saying, where does it cross or touch the x-axis? -2, 1, and 2 and some change. I don't know, somewhere in there. So which of these answers is correct based on that? Right, so there's one there, there's one there, and there's one there. Is it clear, or would you like some more explanation
Could you
or a
explain
better
it a little bit
explanation?
more?
Yeah. So we're making this overly complicated. It's literally asking, what is the X value? What is the X value where it crosses the X axis? And there's three answers. -2, that's the first one right here. 1, and then 2 point, I don't know, 2 or something. Okay. Do any of these appear in this list?
One.
Yes. Okay. Now you might be wondering, well, why aren't they all there? Well, it just says which of the following is a value. Is like it's not saying what are all the values. Is which of the following, and you got to look at the rest of the language, but you're not asked typically in these problems. It's not like your classroom where you need all of them. I don't know why. That's just the way these tests are designed. You're not looking for all of them. Okay. Let's think of another like possibility here. So let's say I give you a graph like this and a graph like this, and I ask you which of the following is a solution. Okay, and this is 3, and this is 4, 5, 6, 7, 8, 9. And let's say the answer choices are 5, 7, 9, 11. Okay. And you're like, wait, where's 3? Well, it just wants one of them, one of the solutions. Okay.
No.
You don't necessarily have to find all of them. I think we worked on a problem last time where it was like, find the solution of one problem, find the solution of the other, and multiply them together.
No.
It was like the absolute value of X, Y. Well, there's multiple solutions, but they just wanted you to pick one of them. Okay, so that is something to consider here, that you're not actually always finding all of them. It's not like in the classroom where you get dinged, not -5 because you didn't find all the solutions, right? That's really frustrating. But that is the nature of these things. They don't actually always work that way. Okay, let's keep going here. All right, hopefully not too bad here. So here's another problem for you to look at.
B.
Which one?
D.
B like boy
No,
or
D.
D? Okay, just making sure. That's why I'm asking here. Yeah. Now, is this odd to you that the variable's on the right that's been factored out?
Mm-hmm.
It's odd to me. I mean, I think it's weird, but that is another thing here. Like, why is it on the right? I don't know. I don't make the tests, but the people who write them, I know what they think. They think like, let's do something really weird. And most students go to A because they add this up and oh, we got 2x's, X squared, right? That's why A is there. Okay. B, I don't know why B is there. Um, C is like you factored out 3 and then I don't know, you just didn't write it or something. But they're all weird, right? Like they're not really like the right factored form. That's why it says equivalent form. Equivalent does not mean factored. It just means, are they the same? Okay. So you see these on occasion. Like this is not a good math question, but it is a standardized test question. All right. Now I've probably lulled you to sleep, and I'm going to put a problem in front of you that is much like, I'm going to show you this. It is much like this problem here. If you recall, we solved it not by reading it, by looking at the answers and then making some decisions. Now, you may not be able to do that for this one I'm about to put in front of you, but I would recommend using that strategy here. Would not read it first. I would look at the answers and then go and see if I can use something about the answers to come up with the correct answer. So go ahead and take a look at this and let me know what you come up with, please.
B,
Okay, how did you come up with B?
because at T0, bacteria dish 1 has 1 and the bacteria dish 2 has 2. And if it's being counted out of 10, then percentage wise it would be 10 and 20.
It is B. Very good. Uh, this is a really tough question, meaning like this is the most difficult type of question you'll see on the test. It's really not that tough if you know the strategy. You have to look at the answers first. If you actually started reading any of this, um, you would realize there's nothing useful here.
Mm-hmm.
There's nothing you need to read here. Like it's great if you're a scientist or you know have time to read, but you don't need to read all that. And we talked about that in the first, testing strategy. You actually go right to the last sentence, which in this case happens to be which of the following, which means you do have to read the answers. And then you go and you say, all right, well, maybe I need to look at the graph, or maybe I do need to go back up here. But in this case, you just need to look at the graph to answer it. Really well done. Really good stuff here.
What would the answer be if the right answer was C, like 50%
uh,
more?
so that's a good question. This is always confusing. So who is 100% more than one? Okay, so just keep that in mind. It's double, right?
Oh, okay.
So let's do it this way. 3 is 50% more than 2. These are good questions. So you actually do get really simple questions on the ST sometimes, like something like what is 100% of 10? More than 10, which is ends up being 20. I'll find some of those. Like we got to be careful not to do so many of these hard problems that we forget the easy ones, because the people that are getting the low scores get the easy ones right. They don't get the ones you just did here right, but you don't want to fall into that, where you're like, which of the following is it? So let's do one more of, actually, let me go find some percent problems. Maybe we should do a few of those. I like that you asked that because we can go, I can find percent problems. All right, let's go. We'll go 3. We won't go super crazy. Yeah, here we go. All right, go ahead and take a look at this and see what you come up with.
A,
Okay, and how did you come up with A? Tell me what you did here.
uh, 20 over 100 times 40,
Okay,
which is just 2 times 4.
so that is okay. So you go to a store, right? And you got a 20% off coupon, which is essentially what this is saying. Okay. 20% off coupon, it's $40. And you're like, all right, that's $8 off. And you go to the register. How much do you pay? You don't pay 8,
36.
you pay 40 minus 8.
Oh, 30.
So what you gave me, and that's why A is there. And I call it this, I say it this way, A is the most common wrong answer.
Oh, 20% less than.
Yes.
I just,
And one word makes all the difference. If it said 20% out of calcium, then it would be A, but it doesn't. And this is classic. I mean, it's good that we're doing it right here. Like you see your mistake, you're like, okay. And like because the reason we don't do it this way is because it's weird. It's weird if you go into store and say, I want to pay 80% of the total. Like we've become used to that we like the discounts. Oh, it's 20% off. But reality is you're paying 80%. You're paying 80%. And that's what you care about. And so 80% is the 32. It's easy to do that, what you just did there. So kind of the rule of thumb here, if you want the rule of thumb for this, it's like the new total is 1 minus the discount times the original. Like this is the shortcut to do it. The discount's 20%, 1 minus 20% is 80% of the original. Or what most students do is what you did there is you take the discount times the original, but then you have to subtract it from the original. You have to make sure you take that extra step here. Now, if you're going the other direction, like let's say you're talking about tax tip increase, some sort of like growth thing, it's 1 plus the percentage this time times the original. And we'll see that here in this example. All right. So go ahead and take a look at this, see what you come up with. Try not to overthink this. It's 1 plus
I
the
don't-
percent.
oh, so it'd be
So
A.
yes, and then your times X, which is the original amount. Yes, very good. I know, like so maybe like you're thinking, well, hey, he just said A is the most common wrong answer. Like, yeah, but that like none of these strategies work every single time. It's like you just gotta muddle your way through and see if you can go with that. Uh this problem is a good one, kind of an extension of the one you just did here. Go ahead and take a look at that, please.
A?
Let's so if it's A here, you have to take into account both the discount and then the sales tax. Now, maybe have you worked a job where you've run a cashier or anything like that in the
No.
past? Okay, so this is, you probably have never had to do this. This is, but the way this works is they first do the discount and then you pay the tax. So let's do them one at a time here. The discount is 20%. So how much are you actually paying of the total?
What?
Like we talked about this in the previous problem here is like you're not paying, it's not 20%, it is 20% off, but how much of the total are you paying when it's 20% off?
Oh, you're paying 80%.
Paying 80%. So it's 0.8 times whatever the original price was, which is P in this case. Okay. So now the way sales tax work, sales tax is 1+%.
It would be D.
Kind of. He's got all the right elements here. The tax is 0.08. So it's 1.08, but you pay that on like whatever the discount is. Like, let's say something is $100. Okay. That's the easy example. With the discount, it becomes 80, but then you pay the sales tax on the 80. You pay 1.8 times the 80. So the correct answer here is C, um, because you first get the discount, then you then apply the sales tax.
Okay.
Any questions, thoughts on that? We're going to go back to some numerical problems, but I just want you to, if
No,
that's,
that makes
if,
sense because it's like the original value is more, so you have to multiply.
yes, exactly, exactly, yeah. Um, there's kind of a really interesting question that I saw in the dental admissions test about like where it's like, and you see this in like the stock market, which is like the percentage decrease and increase isn't always the same to get back to the same amount. And, you see that from time to time. But here you go. Here's a new question for you to look at. This one could be, take a look at this and just let me know what you think here.
So C.
Wait, could you eliminate any answers based on kind of the percentages, like it going up and then it went down? Like, do any of those seem like
A and
you
B.
get rid of? Yeah. And so if you're guessing, you're certainly not going to guess that. This is way too large, but I guess if you don't have any idea, you might think that that's reasonable there. Okay, let's see if I can go throw in one more of these types of problems. Yeah, this is a good one. And then we'll maybe go back and do.
Is it A?
Okay, and how did you come up with A?
Uh, you take the percentages of each one separately and like
Okay, so give me like kind of work. Give me your numbers. I'm trying to see what you're doing to solve this.
I did 140 pounds plus 60 pounds equals 200.
Okay,
And then because a 20% decline happened on the tomatoes, it would be zero point 0.8 times 140, which is 112. And then it would be zero point 0.5 times 60 equals 30 pounds. And then you add those two numbers. And then if you subtract 200 minus 142, you get 58%. I mean, 58 pounds. And
because it's out of
58 over
200. Yeah,
200 times 100 is 29%.
really good. Really, really good. Excellent. Okay, well, that's going to do it for us for today. Great job. So this week we'll get scheduled, and I'll see you next time.
See ya. Thank you.